let's talk about unpacking these standards. What do the students have to know and do? And then we're also going to take a look at what you, the teacher, should be doing in your instructional practices to ensure all of these standards are met. So we're looking at 4. We're talking about the grade level. MD is going to be that domain. Then we have A, which is going to be your cluster. And then the different numbers are going to break down the specific standard indicators that the students need to know. So let's take a look inside and let's see what's going on. When we are clicking directly on the links, if you missed how I got here, I'm clicking directly on this blue underlined link because that means it's a hyperlink. So I'm going to scroll down and that means it's going to take me to somewhere new and somewhere that I need to go. So unpacking the standards, what do students have to know and do in grade 4? Grade 4, the domain that we're looking at today is measurement and data, MD. Here are the clusters. A, where they're solving problems involving measurement and conversion of measurements from a large unit to a smaller unit. B, representing and interpreting data. C, geometric measurement, understanding concepts of angle and measure angles. Within this cluster, we're taking a look at A. How do I know what we're looking at? I'm going to refer back to this document and also the standards that are in the previous slides, which is where we got this from. And you're going to take a look at each one of these because this is what you need to know for 4.7. So here we have A1. These are the standards for mathematical practices here. And this is the specific descriptors for this standard. Now for the aspects of rigor, it says that there are bold components that indicate the explicit aspects of rigor within the standard. Keywords and phrases in the standard indicate which component of rigor the standard is targeting. All 3 components are equally important to student mastery. So for conceptual understanding, you'll see all of these bullet points are bold, which means this is equally important. All of these are equally important in order for students to master this content. So this is what the students should be doing. Understanding approximately how large or small a measurement unit is. For example, they should be able to measure larger distances, knowing that an egg carton is about a foot long. And so that size would be greater than a pin. Right? So that should be something that they are able to do. All right. So notice the progression of how these bullet points are listed. We're not starting down here. We are starting with them understanding how large or small a measurement unit is. And they get that by actually viewing literal objects. You can use what you already have in your classroom. Maybe there's something in the science closet that you could go ask to borrow for your measurement unit. But the more background knowledge you can provide your students with, the greater chance they have for increasing their understanding. Let's talk about the procedural fluency. Describe the relative size of units. 100 meters are in a kilometer, 100 centimeters are in a meter, and 16 ounces are in a pound. Represent a larger unit with smaller units, such as 36 meters, is going to be equal to 360 centimeters, whereas 4 yards is going to be equal to 48 inches. And at this time, you would have your students really kind of develop and kind of see the relationship here. They should be able to then complete their table, which takes them down to this next one. Record measurement equivalents in a 2-column table. Then we have application, right? Notice how this is not bolded here, but it's still here because it is important for them to know. But these bolded items are going to be the explicit aspects of rigor within the standard. Right? So to apply their knowledge, they need to identify patterns in the 2 different measurement systems, customary and metric, engage in problem-solving tasks involving measurement conversions, and then explain why unit of measurement is or is not the best choice for a given item. What the teacher does. We really find this to be helpful for teachers because you're able to then take a look at what the teacher does. Let's take a look at all of this. Begin by teaching students to understand relative sizes of measurement units within one system, including kilometers, meters, that good old meter stick, centimeter, ruler, time to break it out, kilograms, grams, pounds, ounces, right? Liter, 1 milliliter, talking about liquid measurement, hours, minutes, and seconds, time, okay? Students should touch real objects and use measurement tools to measure, then think about and make a connection for measurement units. Relating and thinking about the relative sizes helps students develop a benchmark for the units. For example, a centimeter is about the width of a large paperclip. A meter is a little more than a yard. A kilometer is 3 times the walking distance around the football field. A gram can be thought of as the mass of a small paperclip. A kilogram can be thought of as the mass of an average mathematics textbook, or a little more than 2 pounds. A liter is about the size of a small pitcher. A milliliter is about the size of a drop from an eyedropper. You can plan experiences for students to discover hands-on measurement relationships before they create tables to express measurements in a larger unit to a smaller unit. Have students discover that, or have students use a 12-inch ruler to discover that 3 12-inch rulers or 36 inches is equivalent to 1 yard. So again, they are uncovering this rule before we're even saying, hey, 36 inches is 1 yard. We're giving them the opportunity to literally lay down 3 12-inch rulers to see what that is equivalent to, that yardstick. You don't have a yardstick, you can build it. If you need help doing that or gathering your supplies, you can check with your math ambassador in your building or your math ILT. And of course, you can reach out to your 4th grade numeracy coaches. You need to provide activities for students to create tables to show measurement equivalents with larger units expressed as smaller units within the metric system. Sometimes the tables will be there for them. Other times, the tables they will have to create them. Do that one more time. Sometimes the table will be there and they will just automatically fill them in. Other times, they will have to create that table. They might be given a task where the table is not there for them. They don't need to go through and do a elaborate 11th grade conversion. They should be making their conversion tables based on the rates that you already have posted, and then anchor chart the job knew together as they uncovered what the measurement rule was in their learning experiences throughout your class periods. Fourth graders will need numerous experiences to explore the patterns and see the relationships with those units of measurement. Now we're going to go back up, and in the right side, it's going to talk about what the students do. They learn visually and see and think about benchmark measurements such as a centimeter is about the size of the width of a small paperclip. So the width, not the length. Think about that. Express measurements in larger unit. Express measurements in a larger unit in terms of a smaller unit by recording measurement equivalency in a two-column table. So they use both metric and standard measurement vocabulary. Students should be reasoning about the units of length, capacity, and weight using metric units. Students need to develop a basic understanding of the size and weight of metric units and apply this understanding when estimating and measuring. Students should understand how to express larger measurements in smaller units within the metric system to reinforce notions of place value. So we have the millimeter multiplied by 10. Just take a look at this pattern that we see here. This is something that you can create with your students after they have already experienced and what did they say down here? Explored the patterns to see the relationships within the units of measurement. All right, so these are the measurement equivalents that they will need here. We also have modeling and promoting student usage of using the measurement vocabulary terms. This is going to help them clarify their responses. Make sure that the students have the opportunity to have discourse with one another and their teacher as they experience the measurement conversions and measurement equivalent. We will also need to take a very close deep dive into 4MD-A2. Let's go back to view the other ones that need to be 4MD, A3, C5, C6, and C7, along with 4G-A1 and geometry. Now, I did walk you through how to do that for the first standard. Now it's your job to do that for the rest. Let's get unpacking these standards. Let's start unpacking these standards.